the binomial theorem. So when I expand expressions of the form x plus y to a power, it follows a particular pattern. X plus y to the 0th, anything to the 0th power other than 0 is a 1. X plus y to the first is just x plus y. X plus y squared is x squared plus 2xy plus y squared, because what I'm really doing there is foiling the expression x plus y times x plus y. So x times x is x squared, x times y, and then y times x, and then y times y. And then x plus y cubed is this multiplied by another x plus y. So I would again distribute the x through and the y through and gather like terms. It forms this expression and so on. Now notice that this is x to the 0th, x to the first, x squared, x cubed, x to the fourth, x to the fifth. This is y to the 0th, y to the first, y squared, y cubed, y to the fourth, y to the fifth. In the middle, I have x to the first, y to the first. X to the first and y to the first, that has a degree of 2. Every term here has a degree of 2. X squared y to the first, again, has a degree of 3. X to the first, y squared has a degree of 3. Every term here has a degree of 3. The x's are going down. If I have x to the fourth, then my next one is 4x cubed, then 6x squared, then 4x, then no x's. While the y's are going up, no y's, y to the first, y squared, y cubed, y to the fourth. So this pattern allows me to be able to quickly multiply this out by following the pattern. I start with x to whatever exponent is here, and then count them down each term. And I have no y's in the first term, but I count them up by 1 for each subsequent term. All we need are these coefficients. There are two ways we can get it, and this slide explains what I just explained verbally, so you can pause here and read it. But there are two ways we can get those coefficients. The first way is Pascal's triangle. This is Pascal's triangle. It has ones all down each side of the triangle, and then the two terms above it make the term in the center. So 1 plus 1 makes 2. 1 plus 2 makes 3. 2 plus 1 makes 3. 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 makes 4. And then 1 plus 4 makes 5. 4 plus 6 makes 10. 6 plus 4 makes 10. 4 plus 1 makes 5, and so on. So my next row would go 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and then a 1. And I keep going with that pattern however far I need to generate Pascal's triangle. So this explains what I just said verbally. You can pause here and read it. But the other way I can generate those coefficients is by using the binomial coefficient, n choose r, which is defined to be n factorial over r factorial times n minus r factorial. All right, let's practice expanding this. 9 choose 7 is 9 factorial over 7 factorial times 9 minus 7 factorial. That's 9 factorial over 7 factorial, 2 factorial. Now, if you recall, 9 factorial is 9 times 6 times 5 times 4 times 3 times 2 times 1. I multiply every number below it all the way to 1. So 7 is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 2 factorial would be 2 times 1. So notice all of these terms repeat up here. How did I skip my 8 and my 7? So I'm left with just 9 times 8 in the top and 2 times 1 in the bottom. So the 2 can cancel with the 8, leave a 4. 9 times 4 is 36. Now, notice an easier way to do it is to expand this by saying 9 factorial is 9 times 8 times 7 factorial over 7 factorial, 2 times 1. Cancel the 7 factorials. 8 divided by 2 is 4. 9 times 4 is 36. We get to the same answer. All right, let's do 6, choose 0. That would be 6 factorial over 0 factorial. 6 minus 0 factorial. So that's 6 factorial over 0 factorial makes a 1. Why is 0 factorial 1? How many ways can you choose 0 objects? Only one way. So you have to remember the definition that 0 factorial is 1. So 6 factorial over 6 factorial cancels and gives me a 1. So notice anytime I have a 0 in the denominator here, I'm going to end up with a 1. All right, so we can compute these on the TI-84. Let's see how to do that. If I pull up my calculator here and hit the math key and then arrow over to the probability, option 3 there is my n choose r function. So if I want to do 6 choose 2, like they did in the example, we're going to get 15. Notice 6 choose 2 is 6 factorial over 2 factorial, 6 minus 2 factorial. So that's 6 factorial over 2 factorial, 4 factorial. 6 times 5 times 4 factorial over 2 times 1 times 4 factorial. 30 divided by 2 is 15. Okay, so the way that those become the coefficients in our expansion, how we originally started, is these generate those coefficients in Pascal's triangle. There's no coefficient for the first term. The first coefficient is n choose 1, where n is the exponent. N choose 1, then n choose 2 for the next, n choose 3, all the way up to n choose n minus 1. The rth term here would have n over n choose r, x to the n minus r, y to the r. Okay, well, that would be not quite the rth term. That would be the r plus first term, right? Because like the second term has a 1 here. Okay, and that's gonna come back up in a minute. All right, so I want the binomial expansion of m plus n to the 4th. So following the formula that we just saw would say m to the 4th plus 4 choose 1 m cubed n plus 4 choose 2 m squared n squared plus 4 choose 3 m cubed n plus, there's no more coefficient once we get close to it being the same in the top and bottom. It's just, oh dear, why did I wrote the cube on the wrong place. It should be m n cubed. This is just n to the 4th. All right, so expanding this. Remember, this coefficient is 4 factorial over 1 factorial, 4 minus 1 factorial. That works out to be a 4. This one is 4 factorial over 2 factorial, 4 minus 2 factorial, and that works out to be a 6. And this one is 4 factorial over 3 factorial, 4 minus 3 factorial, and that works out to be a 4. And we get the same thing that we would have gotten using Pascal's triangle. Let's expand a minus b over 2 to the 5th. Notice there's a minus here instead of a plus. So my y term is going to be a negative b over 2. So this is a to the 5th plus 5 choose 1, a to the 4th, negative b over 2 to the 1st. 5 choose 2, bring down the a exponent by 1, increase the negative b over 2 exponent by 1. All the way down till we get all the terms written in. Now go ahead and work out those binomial coefficients. We're going to find it goes 1, 5, 10, 10, 5, 1. Now expand the squaring and multiplying that fraction times the coefficient out front. This is our reduced form. Now in the binomial expansion, we saw that the rth term would be n choose r minus 1 x to the n minus r minus 1, y to the r minus 1. Remember I said this will come up in a minute because we saw that the term was kind of like one ahead. So we're doing the r minus 1 in there. Okay, so let's find the fourth term of a plus 2b to the 10th. So the r is 4, n is 10, the exponent. R is 4 because it's the fourth term. X is this placeholder here, a, and the y is this place here, 2b. So we would have n, choose r minus 1, a to the n minus r minus 1. So 4 minus 1 is 3, so 10 minus 3 is 7. And then 2b to the r minus 1. So if we go ahead and expand that, we get 960 a to the 7th b cubed.